Q8011. When different rated capacitors are connected in parallel in a circuit, the total capacitance is, note, CT equals C1 plus C2 plus C3. A. Less than the capacitance of the lowest rated capacitor. B. Equal to the capacitance of the highest rated capacitor. C. Equal to the sum of all the capacitances. The correct answer is C. When capacitors are connected in parallel in a circuit, their capacitances add up to give the total capacitance of the circuit. This is true regardless of whether the capacitors have different ratings or not. Therefore, the total capacitance of the circuit is equal to the sum of all the individual capacitances. For example, if three capacitors with capacitances of 1 microfarad, 2 microfarads, and 3 microfarads are connected in parallel, the total capacitance of the circuit would be CT equals C1 plus C2 plus C3. CT equals 1 microfarad plus 2 microfarads plus 3 microfarads. CT equals 6 microfarads. So the total capacitance of the circuit is equal to the sum of all the capacitances, regardless of their individual ratings. Q8012. When inductors are connected in series in a circuit, the total inductance, where the magnetic fields of each inductor do not affect the others, is, note, LR equals LR plus LZ plus LS. A. Less than the inductance of the lowest rated inductor. B. Equal to the inductance of the highest rated inductor. C. Equal to the sum of the individual inductances. The correct answer is C. When inductors are connected in series in a circuit, the total inductance is the sum of the individual inductances. This is true regardless of whether the inductors have different ratings or not. Therefore, the total inductance of the circuit is equal to the sum of all the individual inductances. For example, if we have three inductors with inductances of 1 Henry, 2 Henrys, and 3 Henrys connected in series, the total inductance of the circuit would be L_total equals L1 plus L2 plus L3. L_total equals 1 Henry plus 2 Henrys plus 3 Henrys. L_total equals 6 Henrys. So the total inductance of the circuit is equal to the sum of all the individual inductances, regardless of their individual ratings. Q8014. What is the total capacitance of a certain circuit containing three capacitors with capacitances of 0.25 microfarad, 0.03 microfarad, and 0.12 microfarad, respectively? Note, CT equals C1 plus C2 plus C3. A. 0.40 microfarad. B. 0.04 microfarad. C. 4.0 microfarad. The correct answer is A. For capacitors connected in parallel, total capacitance is found by adding the individual capacitances directly. CT equals C1 plus C2 plus C3. CT equals 0.25 plus 0.03 plus 0.12. CT equals 0.40 microfarad. Therefore, the total capacitance is 0.40 microfarad. Q8015. Which requires the most electrical power during operation? Note, 1 horsepower equals 746 watts. A. A 12-volt motor requiring 8 amperes. B. 4 30-watt lamps in a 12-volt parallel circuit. C. 2 lights requiring 3 amperes each in a 24-volt parallel system. The correct answer is C. To determine which option requires the most electrical power during operation, we need to calculate the power consumption for each option using the following formula. Parallel system. Q8016. How much power must a 24-volt generator furnish to a system which contains the following loads? Unit rating 1 motor, 75% efficient, 1 divided by 5 horsepower 3 position lights, 20 watts each 1 heating element, 5 amp 1 anti-collision light, 3 amp. Note, 1 horsepower equals 746 watts. A. 402 watts. B. 385 watts. C. 450 watts. The correct answer is C. The motor has a horsepower of 1 divided by 5, thus 746 watts. 1 horsepower divided by 5 is 149 watts. This is the motor output. The efficiency rating can be used to calculate how much additional energy is required to create 149 watts. 149 divided by X equals 75 divided by 100. X equals 199. Therefore, 199 watts are needed for the 1 divided by 5 horsepower motor with a 75% efficiency. It takes a total of 60 watts to power the 3-position lights. 120 watts are required for the heating element. 72 watts are needed for the anti-collision light. The generator must generate a total of 451 watts.